Okay, going to try and finish this up. We've got proving an identity. I want to show that this is equal to this. All right, so we'll use just the sum formula that we've learned this section. But this is sine of 3 pi over 2 times cosine of theta plus cosine of 3 pi over 2 times sine of theta. And we know 3 pi over 2 is here. So that's the point 0, -1. So cosine's the x-coordinate and sine is the y-coordinate. So sine's the y-coordinate, that's -1 times cosine theta plus, now cosine is the x-coordinate down there, that's 0 times sine theta. This goes away and we just get negative cosine theta, which is the right-hand side. Okay, that was actually not too bad. Another identity, I think this one looks pretty straightforward also. Cosine of pi plus theta equals negative cosine of theta. So using the formula for the sum on a cosine, you get cosine pi cosine theta minus sine pi sine theta. I'm not showing these formulas because you can look them up. And then at pi, that's here, we've got the point -1, 0. So cosine is the x-coordinate, that's -1 times cosine theta. And then minus sine of pi is 0 times sine theta, exactly like the previous problem. This goes away, this goes to this. All right. All right, so tangent of pi minus theta equals negative tangent of theta. So for this one, we can use the formula here, this one right here. So just plugging into that formula, we get that the left side is tangent pi minus tangent theta over 1 plus tan pi tan theta. And the thing is, when you're at pi, which is here, -1, 0, tangent is the y-coordinate divided by the x-coordinate, which is just 0. So you know that this is 0, and this whole thing goes to 0. So you're left with on top 0 minus tangent, that's negative tangent theta, and then over just 1 plus 0, which is 1. So you wind up just getting negative tangent theta. So that's the identity. Okay, so how about this one? Sine of alpha plus beta plus sine of alpha minus beta is equal to 2 sine of alpha cosine of beta. All right, so first use the identity or the sum formula here. This is sine alpha cosine beta, and then plus sine beta cosine alpha, and then use plus, and now use the formula for this one, which is sine alpha cosine beta minus sine beta cosine alpha. And now some things should cancel here. Looks like this and this cancel. And these two are identical. So there's 2 of them. Put them together and there's 2, and that gives you this. Okay, so sine of alpha minus beta over sine of alpha cosine beta equals 1 minus cotangent alpha tangent beta. All right, let's start with the left side. I'm going to do the formula for the top. That's sine alpha cosine beta minus sine beta cosine alpha all over sine alpha cosine beta. Okay, so now let's split this into 2 fractions. So we're going to do sine alpha cosine beta over the common denominator, and then minus sine beta cosine alpha over sine alpha cosine beta All right, so on the first one, this cancel, 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 cancel. We just get a 1 here, minus. And then here on this one, if you look at the betas, this together, that's a tangent beta. And then this over this part right here, that's a cotangent of alpha. And that's the right-hand side here. These are backwards, but it's okay because it's multiplied. So that's the right-hand side. Okay, sine of alpha plus beta over sine of alpha minus beta equals tangent alpha plus tangent beta over tangent alpha minus tangent beta. Okay, I guess I'll start with the left-hand side. Top becomes sine alpha cosine beta plus sine beta cosine alpha over sine alpha cosine beta minus sine beta cosine alpha. Okay, what to do now? Do I want to split this into two? I don't really want to split this into two. Let's see, where are we trying to get? We're trying to get to this, right? So let's think about how we can make this happen. If I wanted a tangent of alpha in the top left corner, if this right here needed to become a tangent alpha, I would have to divide it by, let me see, I'm going to multiply 1 over, so I have divided by cosine alpha. That would give me sine alpha over cosine alpha. That would give us the tangent, but then I want the cosine beta to be gone, so I put cosine beta here. Now, whatever I do on the top, I have to do on the bottom. And I'm going to do this and hope it works. It should. Let's see. Multiply top by this and the bottom by this. So it's going to distribute here and here and then here and here. Okay, so when I go from here to here, I guess I'll write this all out. We'll have sine alpha cosine beta over cosine alpha cosine beta. And then plus, now when I go from here to here, I'll have on top sine beta cosine alpha over cosine alpha cosine beta. Then the whole thing over, now I do the same thing on the bottom, distribute here. So I get sine alpha cosine beta over cosine alpha cosine beta minus, now this right here, sine beta cosine alpha over cosine alpha cosine beta. All right, good things happen now. See, cosine beta is canceled, so that right there gives me tangent alpha. Okay, on this one, those two cancel, and I get sine beta over cosine beta. That would give me tangent beta over, and now here, let's see, cosine beta is canceled. I get sine alpha over cosine alpha, that's tangent alpha. And then the minus sign, and then over here, the cosine alpha is canceled. I get sine beta over cosine beta, that's tangent beta. And that is this. Tricky, this little thing right here is tricky, but I got it because I knew where I needed to go. So that's what kind of influenced me to come in with this on top and bottom. All right. All right, so sine alpha plus beta times sine alpha minus beta equals cosine squared beta minus cosine squared alpha. Let's prove this. Okay, so the first one, this right here becomes sine alpha cosine beta plus sine beta cosine alpha. Now all of that is multiplied times this one, which is sine alpha cosine beta minus sine beta cosine alpha. And now I can FOIL. So this times this, the sines hit each other, becomes sine squared alpha. The cosines hit each other, becomes cosine squared beta. And then very important, when I do this one right here, to here, let me go ahead and write out what it'll be. It'll be minus, let's see, I'll have sine alpha cosine beta times the other one, which is sine beta cosine alpha. But look, when I do the middle one, it's a plus, and now it's sine beta cosine alpha. That's the first one over here, times the other one, which is sine alpha cosine beta. Then the last multiplication is here to here. One of them is positive, the other one's negative, so I get minus. And then looks like we have two sine betas being multiplied together, so that's sine square beta, and two cosine alphas being multiplied together, so that's cosine squared alpha. And the big thing was that these middle ones go away. So what you're left with is, oh, okay, so we're not done. Yeah, okay, I see it here. So we're left with sine squared alpha cosine squared beta minus sine squared beta cosine squared alpha. Now both of these, oh no, they both don't have, oh no, these do cancel, right? Let's see, sine alpha, cosine beta, cosine alpha. Yeah, this looks okay. But I thought I was gonna be able to factor out a common factor here. Difference of squares, no. Let's see. Let's get these all in terms of cosine. I think that's the only way we're gonna be able to do this. So take this and make this 1 minus cosine squared alpha. And then make this one cosine squared beta. And then minus, turn that one into 1 minus cosine squared beta, and then cosine squared alpha. Yeah, this is probably going to work. Okay, now distribute here and here. So we get cosine squared beta minus cosine squared alpha cosine squared beta. And then here we distribute the negative sign through, so it becomes minus 1 plus cosine. Oh, you know what? Let's do it this way. Let's keep the minus sign here for now. Let's distribute here and here. So we get cosine squared alpha minus cosine squared beta cosine squared alpha. And now distribute the negative sign through. So we will get cosine squared beta minus cosine squared alpha cosine squared beta. That's the first two. Distribute the minus, so we get minus cosine squared alpha plus cosine squared beta cosine squared alpha. And I believe that this and this cancel, which leaves you with cosine squared beta minus cosine squared alpha, which is this. Seems like there maybe would have been an easier way there, but it worked. So I'm happy. Okay, so how about this? Find the exact value of sine inverse of 1 minus cosine inverse of a half. Okay, so what we need to realize is that this is alpha, this is beta. So ultimately we want sine of alpha minus beta. But we know that that is equal to sine of alpha cosine of beta minus sine of beta cosine alpha. And remember what alpha and beta are, they're right here. So this becomes sine of, well, alpha is arc sine of 1. And then cosine of beta, but beta is cosine inverse of a half. And then minus sine of beta, but beta is cosine inverse of a half. And then cosine of alpha, so cosine of alpha, but alpha is sine inverse of 1. All right, so there's a couple of easy ones here. This is just 1 because the inverse, the sine and sine inverse kill each other off. I'll leave that one open. This one also is easy because they kill each other off. You get 1/2. Minus now here, the way you look at this is that this here is beta, right? So this is some angle. Cosine inverse of a half is an angle. So what you're saying is where, since we're doing cosine inverse here, I'm talking about this one, I can only look in the first and second quadrants. Cosine is the x coordinate. So where's the x coordinate? 1/2. And that happens right here. Right, that's 1/2 √3/2. So that angle there is actually, this is just sine of pi/3. And then I know that that is, let me see, these multiply together as 1/2 minus, so sine is the y coordinate there, which is √3/2 times, now I need to do the same thing for this. So sine inverse of -1, this is your alpha. So that's saying where doing sine inverse, you have to be in the first or fourth quadrant. And so where is the y coordinate 1? And that's going to be up here at pi/2. So this is really just cosine of pi/2. The cosine of pi/2 is the x coordinate here, which is 0. So that just kills this off. That all goes away. So all you're left with is 1/2. Let me check this one. I'm on the last one. All right, this is the last one. It's the one that's going to require the most work. Okay, here we go. Cosine of tangent inverse of 4/3 plus cosine inverse of 8/17. Okay, so I'm going to look at this as being alpha and beta. And so what we really want to know is what is cosine of alpha plus beta. And then this is equal to, and I'm having a little brain fart here, it's the opposite. Yeah, so this is cosine alpha cosine beta minus sine alpha sine beta. Now, if we start plugging things in here, let's see, cosine of alpha. So alpha is arctangent of 4/3. And then cosine of beta, the beta is cosine inverse of 8/17. Then minus sine of alpha, which is arctangent of 4/3. And then sine of beta, which is sine of beta, which is cosine inverse of 8/17. Okay, any of these easy? This is the only one that's easy. That's just 8/17 because they kill each other off. So let's talk about alpha. Alpha's here and alpha's here. Here's beta. All right, let's talk about alpha first. Because alpha involves arctangent, we have to be in the first or the fourth quadrant. And arctangent being a positive number here means that we have to be up in the first quadrant because tangent is only positive there. Remember, this is really saying this. This is saying that alpha is tangent inverse of 4/3, which means that tangent of alpha is 4/3. And since tangent is a positive, that would have to happen in the first quadrant, not the fourth. And tangent by definition is the y over the x. So this point here is the x is 3 and the y is 4. So if we can just figure out the radius of this, right, then we can have all the other pieces. So this is 3, this is 4. And then if you solve for r Pythagorean, you'll get 5 here. So why is that important? Because this question is really asking, right here, this piece is really asking, what is cosine of alpha? Well, if this is the triangle made off of alpha, cosine is the adjacent over the hypotenuse, or the x over the r. So this should just be 3/4. Now we still have times here. Now the 8/17 we didn't have to work for. That's separate work here. That's part of that. So back here, when we get to this sine of, this is sine of alpha, but I should say this is sine of alpha here. Sine of alpha is, again, this picture, it's the opposite over the r, or the y over the r, and that should be 4/5. So 4/5, and then times, now we have to do the same thing for beta. Okay, so for beta, this is really telling us that cosine of beta is 8/17. And because we are involving the inverse cosine, we can only be in the first and second quadrants. And because cosine is positive, we have to be in the first quadrant. And this is going to be our x over our r. So we know this is 17, and we know that the x coordinate must be 8. We need the y coordinate to be able to figure out sine of beta, right? Because this really means sine of beta. So Pythagorean, you get 8 squared plus y squared equals 17 squared. So it's a perfect square. 17 squared minus 8 squared equals 225. Oh, okay, that is. So you should get y is equal to positive or negative 15, but we're going to take positive 15 because we're in the first quadrant. So we know that that's 15. So sine of beta should be the y coordinate over the r, which is this. Okay, so I think we're here. We're going to have 3 times 8, that's 24 over 4 times 17 on our common or our denominator, then minus the 4 times 15, which is 60 over the same denominator, 68. And then 24 minus 60, what is that? 36, negative 36 over 68. And that reduces to be negative 9 over 17. Okay, let's see. Let's check this. It's the last problem. So negative 9 over 17. Oh, crap. What's going on? What's going on? Oh, did I do a plus? No, I didn't. It was plus here. Whoa. Did I? Oh, I see what I did. I messed up. Sorry. This was 4 times 17 here. And that was 68. But 5 times 17 on this one is 85. So I messed this up. Pen, hold on, come on. I messed this up. Okay, glad I caught that now. Okay, so when I multiply here to here, that's 85. Okay, let's reduce these fractions before I start trying to subtract these. It still doesn't seem right. 17, 3 over 4. Cosine. Oh, wait, yeah, cosine. Something is wrong right here. Cosine over here is adjacent. Oh, right here, 3 over 5. 3 over 5. I messed this up right here. Cosine of alpha, 3 over 5, not 3 over 4. Don't know why I wrote that. That's 5. Now that's 85. And now that's negative 36 over 85. Okay, that's the answer. Okay, my mistake there. All righty. That is it. Happy about that.